So now, like I said, we're starting with the OSI reference model. So this OSI model, like I said, which is the open systems interconnection. Now, this is used to describe the function of a network system. I'm recapping so that you'll be able to understand it. It is used to describe the function of a network system. And now, when you talk about OSI model, we talk about layering. Remember, I mentioned when we have the OSI and the TCP IP network model, and I said they are what? Layering. The OSI model has 7 layers, while the TCP IP model, tends to what? Merge these layers together to make it what? One. Like the layer 1 and layer 2 of the OSI model, which is the physical layer and the data link layer. They are meshed together in the TCP IP. We'll see the comparison, but for now, let's stick to what? OSI model. But one thing about this numbering, it is what? Numbered from the 7th layer down to what? The first layer. And the 7th layer here is what is called the application layer. Now, this layer, so the 7th layer is called what? The application layer. This layer, or let me say, this is the layer at which communication partners are identified. It's just like, is there someone to talk to? Yeah, network capacity is assessed. With the network, let me talk to them right now, and where the data or application is presented in a visual form that the user can understand. So this layer is not the application itself, but it is the set of services and applications should be able to make use of directly. Although some applications may perform application layer functions. Then if we go here, go to this place, we'll see the application layer here. You can see application, presentation, session, transport, network, data link, and physical. But just go back to the file itself. Let me scroll down. So you can see we have the other standards, the ISO, ITF, and the likes. You can read that by yourself, but let's go back to what the layering. So, yeah, to go further, it say what? Application layer what? Provides system application interfaces for user application software. Let me see if I can get anything further. Okay. All right. So we now have what? The 6th layer, which is what? The presentation layer. And this converts data format to ensure the application layer of one system can identify and understand the data generated by what? The application layer itself. So if I go back to, let's say I open a new tab and just type in, let's say OSI model. Okay, my network is taking time, but I'll just, okay, it's up. Let me say I go to images, and let me pick on this image. Okay. Okay, let me click out. There's something I'm trying to show you, but if I'm not able to see that. Okay, let's just move on for the sake of time. So we now have the presentation layer, like I said. Okay, this layer is usually part of an operating system and converts incoming and outgoing data from one presentation format to another. For example, from clear text to encrypted text at one end and back to clear text at the other end. Then we now have the fifth layer, which is what the session layer. So this establishes, manages, and terminates communication sessions between two parties and determines whether a party can initiate communication. And to go further, you can say so the layer sets up, coordinate, and terminate, conversation. Its services includes, to add to that, authentication. It also, and reconnection after an interruption. So you are doing something and you're being interrupted, it will be what? Reconnected back. That is done by what? The session layer. And on the internet, we have TCP, which is the Transmission Control Protocol, and UDP, which is the User Datagram Protocol, which provide these services for most applications as well. Then we now have the transport layer, which is the fourth layer. And this layer manages the packetization of data. That is, when we talk about devices, we know of router, which I mentioned earlier. So this router helps to what? To determine route with various protocols. Like I said, the protocol are a series of defined set of rules, and conventions in which network devices like computers, switches, and routers must comply in order to communicate. So you need, this to be able to what? Define this set of rules. And the data in routers in the network layer is called what? Packet. So the network layer again, the transport layer, which is layer 4, which I was playing. This layer manages the packetization of data, then the delivery of the packet, including checking for errors in the data once it arrives. On the internet, TCP and UDP provides these services for most applications as well. So TCP, which is Transmission Control Protocol, is a connection-oriented protocol, while UDP, User Datagram Protocol, is a connectionless oriented protocol. So, there are other places where we will explain this further, TCP and UDP as a chapter, but it's beyond the scope of this chapter. That is just the starting point of what TCP. So layer 3 is what? The network layer. So this enables what? The transmission of data from one or any node at all to any other node based on the network layer addresses or address information included in the data. And to do this, you need what is called what? A router. So you will find a router in a network layer, and the data is called packets. The data is called what? Packet. So this layer handles addressing and routing. So a time will come, you will be taught what is called IP addressing. This layer, which is what the network layer, handles that addressing and routing. So, like I said, what is a router? I'll just explain again. A router is a physical or virtual appliance that passes information between two or more packets, switched computer networks. So this layer enables what? Routing data that we get, just like we saw from the sender to the receiver. So it passes through stages. It is what? The router that enables all this routing to occur, sending it from one direction to another, you know, to another or to the destination. A transmission that is needed to what? Occur. Then what protocol do we find under what? This network layer. The protocol is called what? One of them is Internet Protocol, IP. Then the second layer, which is what? The data link layer, number 2. This what establishes a logical or data link through adjacent nodes connected to a physical link and performs direct point-to-point or point-to-multi-point communications on the data link. And the device you can find here is what is called a switch, and you know the old one is what is called a hub. But and to explain further, this layer sets up links across the physical network, putting packets into network frames. Now, these packets, that is the data itself, the payload, data payload. The data in the data link layer is called frames, F-R-A-M-E-S, frames. While in the network layer, it is called what? Packets, P-A-C-K-E-T-S. So now back to the data link layer, which is layer 2. In this place, this layer has 2 sub-layers. The logical link control layer, and the second one is what? The media access control, which is what? MAC. So time will come, you'll be hearing MAC addresses. MAC, media access control. Now, this MAC address is a unique identification, let me say, number to every device. Like your Bluetooth has a MAC address, your infrared has a MAC address, your laptop has a MAC address, your phone has a MAC address, your wristwatch that has internet connectivity, maybe that Bluetooth sharing and the likes, has what? A MAC address. That Bluetooth itself in the phone that connects you to the wristwatch that connects you to your phone has what? A MAC address. The hotspot that was created in your phone is also what? Having what? A MAC address. And this is created by OEMs, which is called what? Original Equipment Manufacturer. And there are various type of OEMs, which I will not go into in order not to bore us. Then the MAC address itself has what is called the so from there you have MAC address types, which include Ethernet. We saw IEEE 802.3, which is IEEE 802.3, and 802.11 wireless specification, and so many other things. So when you hear the physical layer, which is what the layer 1, you know we are talking about cable. Yes, network cable. It could be fiber, it could be Cat 5, Cat 6, could be, you know, with various speed. It could be optical or electrical signal. But the major thing is that it transfers data in what is called bits. That is why you can see this 0 and 1 here. That is why you can see this 0 and 1 there. So this physical layer conveys the bit stream across the network, either electrically, mechanically, or through radio waves. So the physical layer covers a variety of devices and mediums, among them cabling, connectors, receivers, transceivers, and repeaters. So I'll just talk about the repeater a bit. Now, take for example, you want to connect something from Victoria Island to, let's say, from Eko Hotel now to Aja. And you know, as you are laying down these fiber cables under the ground, it might get to a point, the length is too much. So for you to add that continuation, use what is called a repeater, which will help you connect the 2 mouths of what? The fiber, the end and the starting together, and they get connected together, and you are able to what? Continue the laying of what? The network cable, and it's able to what? Get to what? The ending part, as the case may be. So we just scroll down. That is that about the OSI model. And let me reduce this size. So you can see more explanation from this side. 7th, application, presentation, session, transport, network, data link, physical. Then it comes back again here. It's sending from this PC down to what? Another PC. That is what this is showing here. But if I scroll down, you will see it properly. Remember that first time, that is just a simple what? Data encapsulation and what? Decapsulation. So yeah, your data is what? Packaged in the application layer is what? Then it's not sent down. When we get to chapter 3, when we are discussing about Ethernet, we will explain further, where we have the input buffer, output buffer, and the likes. So yeah, the data that was encapsulated, that is packaged together, like we saw in that first diagram, is not sent from this first computer here as bits, ones and zero, is passing through what? This cable. That is why you see this wave here is representing 1 and 0. So when you get to what? This place, it is what? Decapsulated as it is going down, where the person is able to see it in the representation layer and the application layer at large. So I'll just put it, let it occupy the screen back. All right, great. So we have TCP IP. Like I said, the TCP IP is the model that is used now mainly for networking purpose. And I won't be talking much because it still contains these layers, but it's not, having this layer separated as 1 to 7. But I will just, let's read us through here. Okay. You can see in figure 1.6, we have the standard, which we have 4 layers here. Application layer, which combines the application layer in OSI model, representation layer, and session layer as what? 1, which is called what? The application layer. Then the transport layer is what? The same as what? The transport layer. And this is what the standard one. I'm using the standard one. Then the internet layer is what is called the network layer in the OSI model. While the network access layer is a combination of the physical layer and the data link layer, 1 and 2. But let me reduce this a bit so that we'll get a feel of everything. You will now see in the pair TCP IP model too, is breaking down into 5. Some network engineers like using 5, while some other network engineers like using 4. So as the case may be, the only addition to the TCP IP network layer here is that the network access layer is divided into the normal layer 1 and layer 2 of the OSI model, which is what? The physical layer and the data link layer. Then the network layer here is called network layer in the OSI model, but in the standard TCP IP model, it's called what? Internetwork layer. So that is just it about the TCP IP protocol suite. So the standard TCP IP model has 4 layers, which I said. The network access layer corresponds to the layer 1 and layer 2 of both the pair TCP IP model. It's just explaining what we have down there. So, okay, I will just leave this. Or, okay, we'll just look at this quickly. Okay, let me look for, okay, let's start from here. The reason why the OSI model protocols may be unfamiliar is that when designing and applying the internet and other network protocols, so most designers, sorry for my connection, most designers opted for the TCP IP protocol suite instead of the OSI protocol suite. In the OSI model, we typically refer to the data unit of each layer as a protocol data unit, which is what? PDU for short. For example, the data unit in layer 6 is called what? Layer 6 protocol data LU. In the TCP IP model, we typically refer to the data unit in the physical layer as what? Bits, which I said, bit stream, ones and zeros, like our normal binary number, ones and zeros. We'll see that in IP addressing where we'll do calculation with the bits. So that in the data link layer as what? A frame, which is what the layer 2. Like I said, I'll explain, it is what? A frame. The data is called what? In layer 2, which is called what? A frame. And you can find this with the use of what? Switches and hubs. I mean switches for large. And these switches, we have both layer 2 and layer 3. And that in the network layer as what? Packet, which as a packet, which I've explained. In the transport layer, a data unit encapsulated with TCP is referred to as segment. And that encapsulated with UDP is referred to as a datagram. So TCP segment, which is what? A connection-oriented protocol. Then UDP datagram, which is what? A connectionless oriented protocol. And in the application layer, a data unit encapsulated with HTTP, which is Hypertext Transfer Protocol, is referred to as HTTP datagram. And that encapsulated with FTP, that is File Transfer Protocol, is known as File Transfer Protocol datagram, FTP datagram. So for short, if you look at this diagram, it shows all that explanation that has been given. Physical layer, bitstream. This is the pair TCP IP model. Data link layer, Ethernet frame. Network layer, IP packet. Transport layer, TCP segment. And the application layer, they'll use one of the example, the HTTP datagram. Okay, these are questions, we'll just leave that. So we now have network type. So there are various types of networks. We have LAN, we have WAN. So this LAN is local area network, wide area network, private network, public network, intranet, extranet, amongst the others. So we'll just leave that and move. So what we want to quickly look at is these networks. And I hope not to waste our time here. So as you progress through this section, please pay attention to the following points. Definitions of LAN and WAN and the differences between them, common LAN and WAN technologies, the characteristics of networks with different topologies. After completing this section, you should be able to describe the basic concept of LAN and WAN. 2, understand the basic state of LAN and WAN. And 3, understand the characteristics of network with different terminologies. Like I said, what is LAN? LAN is what? Local area network. While WAN is what? Wide area networks. So basically, I will just say LAN is the interconnection of what? Various switches in a, let's say, in the network. Let's just say in a building now. And, it's connected with the layer 1, which is what? The Ethernet cable. It could be radio, which we mentioned, radio waves or microwaves. It could be various forms of electrical signal or opticals. It could be fiber optics cable. It could be Cat5 cable. It could be Ethernet cable. It could be serial cable and various other type of cables. So we can see here, LAN. Coverage is generally within a few kilometers, like I said, just within a building. And it's mainly used to connect several computers, terminals distributed within close proximity of each other. So when we say terminal, we also mean node. Like in your computer now, you have port. And the devices like the switches also have what? Port. So by the time you connect your computer with a network cable, and that network cable is connected to a switch, and the switch is connected to what? A router in let's say a server room. A server room is where you have maybe you just have a small network within your company, your switches, your maybe router, your other devices like Riverbed, and maybe the small ISP device. That one connects us to the internet directly. So, but we'll see that in the LAN, they have various type of technologies, and we have what is called token bus, token ring, fiber distributed data interface, FDDI, Ethernet, wireless LAN, and the likes. And it has various type of network, which we will see later, like bus topology, like star topology, like mesh topology, which is fully meshed. We also have partially meshed, and various forms of topology as the case may be. But let's just continue. So we have one, which means wide area network. So the term wide there simply means it can cover a lot of space. So you can have, just like we saw in that part where by someone sends a phone and it gets to another destination, let's say from Abuja to Lagos. That is wide area network. You can be in Lagos and you are connected to Abuja through the internet. That is wide area network. But if you are in Lagos and you are connected within the same building, that is what local area network. So you can see mainly used to connect several LANs distributed across great distances. That is what I just explained. If you have a multi-tenant building, when I say multi-tenancy, I mean, let's say a company has various branches in Lagos. So when they connect their office, they connect to the office network. Let's say they have 2 offices in Victoria Island, one in Eko Hotel side, the other in let's say Ahmadu Bello. Then they have another in mainland, like 3 branches. So this, and they are in different places. When you connect all these LANs together to a network, it is called what? The use of what? Wide area network, because wide area network connects many LANs together. That's why I see the first bullet point said what? Coverage generally ranges from a few kilometers to thousands of kilometers. And this involves telecom operators' communication lines. Remember, I mentioned the use of ISP in your server room. You have your cables, you have your switches, your layer 1, your layer 2 or layer 3 switches. Your layer 3 switch can also behave as a router, which is the network component. So the router can have what is called an aggregate router, and various other type of router, which I don't want to bore us with this word or confuse us with it for now. Then we now have some examples given here for the wide area networks. For example, you have your T1, E1, T transmission 3 or E3. We have your S25. You can browse all this. We have your high level data link control, which some people use it for, like, okay, let's leave that because I don't want to break it down too much. You have your point to point protocol. We have your integrated service digital network, ISDN. We have frame relay, asynchronous transfer mode, synchronous, as the likes. So this is an FDDI. This is an example of an FDDI, token bus network, and FDDI network topology. So this is a combination of them. I don't want to explain FDDI too much, so we'll just leave that. We'll just go down. So let's look at what forms of network topology. Now, looking at this is called a star topology. Now, let's say with this topology, they say all nodes are connected through a central node. So this device here at the middle is the central node, and you can see it's connected to what? The 4. But the disadvantage of this one is that it's simple to create, right? But the disadvantage is that if this device at the middle fails, the other devices will also fail because they will not have opportunity to receive information from what? The internet. So network communication will be disrupted. So that is that about the star topology. We now have the bus topology. So in this bus topology, you can see a straight local area network is created, or a straight cable is created. Then in each of them, the nodes are what? Connected. It's very simple to install. You can see various nodes are connected to these devices. But the problem is that if, let's say, in this third part, if you can see the movement of my cursor up and down from the left, if you count after the third one, if this side cuts, it means that these 2 will be cut out of the network communication. Every device that is connected to this two devices will be what cut off of this network, and to be very what bad, right? And we will not be able to what get connected. That's why I said failure of the bus topology will disrupt all network communications. All nodes connected to the bus can receive information sent out from any given node, lowering security. And you can see the advantage, which you can read from the screen, as the case may be. Then we now have what is called a ring topology. You can see this is a ring, it has formed a ring. So all nodes are connected within a single closed ring. Advantage, such shorter cables length than other network topology. You can see don't need to waste a lot of cables. It's very short. And the disadvantage is that adding new nodes will disrupt network communication, because the reason is that you have to cut off. Let's say you cut off this and you now add another one, and by so doing, this network is disrupted until the connection is completed. Then we now have what is called tree topology. So tree topology, the advantage is that it's easy to expand by connecting multiple star network. And we have star topology here, if you can still remember, at the top. Then when you come to the bottom, we have this star, 1 star, 2 star, and you can connect more star by just connecting a cable to this place and create another star here. Now, but another disadvantage is that if this cuts here, then every device is connected to these nodes. To these 3 devices at the bottom. Every computer, every tablet connected to this will also lose network communication. So it causes disruption of network communication. Then we have what is called fully mesh. This fully mesh is highly reliable and communication is efficient. But disadvantage is that increased cost, because the more nodes connected, the greater the number of physical ports and cables required. So it's very problematic to expand. Then another thing is that we have the word called redundancy. So redundancy, let me take it in this scenario. You have your wallet in your pocket. Then you have some money you place under your socks, under your stockings. Then as you are inside the bus, you enter one chance, what is called one chance. And you are obtained. Your phones, your wallet, everything is taken from you, your wristwatch. But they left you with your clothes and your shoes. And now you can enter another bus comfortably because you have another money that you've placed under your source. That is called what? Redundancy, in a layman explanation. That is why we have what? High reliability. It means that if I cut this link now, this device that is here, the devices, the PCs that are connected to it will still receive communication. There's no disruption, because you can take another path to reach it from this side to reach it, right? Then we now have we have partially merged, which is less reliable than the fully meshed, and the cost is less expensive than the fully meshed, but it's functional in the same way. So okay, transmission, media and methods communication. Okay, let's just quickly look at this. So what this method is talking about, this transmission, media and methods of communication, is talking about duplex. Various of duplexes. I will just try and see if I can see it here. Okay, we have simplex, half duplex and full duplex communication. I will just explain it briefly. I just want us to take our time to read it fully because of our time. So the simplex, this is where you have your phone, or let's say a walkie-talkie, for example, and as you are speaking, you say, sorry for the break in transmission. So the simplex here, we are talking about, let's say a walkie-talkie, for example, and I said, Kingsley, let me use the name Kingsley again. Kingsley, how are you doing? Over to you. I drop. Kingsley will say, John, I am fine. Over to you. He dropped. So simplex, one person is allowed to talk before the other person. Then, so it's just a method of communication. Let me see. Then we now have half duplex. We now have half duplex. 1 minute. So they have duplex or semi-duplex. So in this system, both parties can communicate with each other, but not simultaneously. So the communication is in one direction. An example of half duplex is a walkie-talkie. Sorry, the example I gave for simplex is what? Half duplex. Then we now have full duplex. In this full duplex, everybody can communicate the same time. For example, your mobile phone, everyone can what? Communicate. If I'm talking to you, you can also what? Talk at the same time. So it's a two-way form of what? Communication. Then what is there again? So the simplest communication is a communication channel that sends information in one direction only. So yeah, it just was send information in what? One direction only. So that is that for simplest. So transmission media can radio. These are the various type of cable, like I said, under what? The physical layer. We have what is called the coaxial cable. And for those people that are DSTV repairer and we use on our network, our television and the like cable, that is what they use, the coaxial cable. We also have the twisted pairs. We also have the untwisted pair. We have different ones, as you can see from this table. The untwisted pair, we have different type of them. Cat 1, Cat 2, Cat 3, Cat 4, Cat 5, Cat 5. You remember I was mentioning Cat. So we have optical fiber, which is a very fast transmission cable. So it allows communication to actually what? The ones and zeros to actually what? Reach the destination on time from what? The source or the sender, as we saw. So the receiver is called what? The destination. So the method of communication, serial and parallel. So, okay. Now, what I was trying to explain from the simplex and duplex, this is it from the method of communication. So the simplex, you can see, it's just a one-way communication. Let's say your DSTV now, sending you signal, or your cable network sending you signal. So you receive it at once as well, the simplex. But here's a walkie-talkie. If A is talking, B cannot talk. If B is talking, A cannot talk. As you can see, this arrow pointing, there's no crossing of it. X, that's why I see or. B is talking, the arrow going to A, there's no crossing. Say, for example, Mr. B, how are you doing to you today? Over to you. Then Mr. B will say, I'm fine. Mr. A, how are you doing to you? I mean today, over to you. And that's how it happens. Then full duplex, Mr. A and Mr. B, they can talk at the same time. So that is it. And that is it about this chapter as we round off the chapter and move on to what chapter 2 in our later discussion.